Hello students, welcome back to my channel Maths Made Easy with AB. Today in this video we will be learning a very important chapter inside functions, which is mapping of functions. So this is practically going to be a continuation of what you have learned in earlier videos. We have seen domain, range and odd and even functions, various aspects of functions we have seen. We have also seen periodic function in the previous video. Range, several examples, domain, several examples we have seen. We have also seen monotonic functions, and students, let me tell you, in monotonic functions, basically just I'm writing it down, monotonic functions. Yeah, so monotonic functions will actually be helping you understand mapping of functions. So in the info icon I will be linking monotonic functions, so at least you should have seen this video before going into this chapter, mapping of functions, because there were few aspects of mapping of functions, although I will be telling you there in this video also, but you will get to know in monotonic functions how we had solved it. So we had dealt with increasing, strictly increasing function, strictly decreasing function, non-increasing, non-decreasing functions, and those are actually useful in this chapter, mapping of functions. Students, if you are liking my series on calculus and functions, I'll request you all to subscribe to my channel and like the videos. Do share it with your friends, school friends, or whatever, which all place you visit. And I thank you for your support that you have shown till now. I have seen several doubts, queries coming up in the comment section, and I have tried my level best to solve those. Yeah, if you still have any queries, you can quickly comment, and maybe we can get into the solution part. So without wasting any other time and maybe delaying it to start, so let's get started with meaning of mapping of functions. So students, I will not give you any particular definition or very tough things to understand. I'll just teach you the basics of mapping of function. Yeah. So what does mapping of function actually mean? So say you have already seen this is one set. So this is set A and this is set B, right students? This is set A, set B. Till now we have seen graphs, right? We have seen if we put the value of x, we get the value of y, right? So that's the function. So basically I'm drawing a graph also over here. So basically this was a graph, this was your y-axis, this was your x-axis. So for value x1, for this value corresponding, you are getting a value of y1, right? And this was for the function, say y is equal to fx. This was for a function y is equal to fx. So basically understand it very simply that x1 was related to y1. So this point was x1 comma y1, right? And this was that machine that was producing the value of y1, right? You are putting the value x1, you are getting y1. x2 if you put, you will get y2. x3, y3. So basically these elements you see is part of a function, right? So this one was x1, this one was x2, this one was x3, this one was x4. For x1, say for x1 you are getting y as y1. For x2, say for example you are getting y2. For x3 you are getting the value y3. For x4 you are getting, say, the value of y4. So the relation that you see, so the set that is formed by combining the numbers x, x1, x2, x3, this is one set, right? And this was set A and this was set B. So by a particular function, these two sets are related, and this was the mapping actually. This was the mapping y is equal to fx, right students? This was the mapping y is equal to fx, and this is the function. So a function can look somewhat like y is equal to x square, say for example. So basically one value of x1 is 1. So if the value of x1, so I'll write it with a different color pen. Say if the function is y is equal to x square. So basically this is defined as y is equal to x square. This relation is defined as y is equal to x square. So what will mapping mean basically? So if you have a point 1, so y1 will be 1. If you have x2 as 2, this will be 4. So basically square of that. x1 is 1, square is 1. 2, 4. If you have 3, you will be mapped to 9. If you have 4, you will be mapped to 16, and so on and so forth. So this is basically how the mapping is happening, right? If the function is x square plus 1, say for example, if the function is y is equal to x square plus 1, not x plus 1 whole square, it is x square plus 1. So these values corresponding will change. these values corresponding will change. This will become 2, this will become 5, this will become 10, and this will become what? 17, right? X square. So if you put x is equal to 1, you will get 1 square, that is 1 plus 1, 2. If you put 2, 4 plus 1, 5, and so on and so forth, 10, 17. So actually, and you have a graph for y is equal to x square. That is a parabola. We have already seen that in Play with Graph series, students. So it's a request till now, if you have not seen my videos, do go through those videos for super solid understanding. And I bet you students that I have made it the simplest videos I can. And for any layman, if you have any difficulty, I'll make you perfect for joint entrance examinations. And I'm pretty sure if you see those videos, you will easily crack any joint entrance examination, any examination that pertains to mathematics, that pertains to calculus that you have seen. Yeah, so that's my guarantee I'm giving you. If you have any difficulty, we can connect one-on-one. And that's my motive of this channel, students, to teach students and to make them fundamentally very strong. Yeah, so let's get started. So let's get started. We have already started it. So let's continue. So y is equal to x square plus 1. So students, y is equal to x square graph, you know. Y is equal to x square plus 1, you know by transformation of graphs. We have also seen those videos. So basically these are related, and this is the mapping that is happening. Yeah, this is the mapping that is happening. So basically A and B were two non-empty sets. A and B were two non-empty sets. You had some elements in A and you had some elements in B, and F is a rule, right? So F, y is equal to fx, is a rule that associates every element in this set with this set, right? Every element is associated, right? This set is associated with this set by some rule. The rule here is x square plus 1. Before this were 2, 4, 9 and 16. That was y is equal to x square. So that was the rule that associated this set A with set B, right, students? And understand, so that corresponding this thing that is called a function or a mapping from set A to set B. This is what is called the mapping of a function. Right, students, this is what is called a mapping of a function, or y is equal to fx is the function. Now let me tell you some important points over here. We have already seen these points earlier, but again I'll focus on these points. So one thing is domain. We have already seen how to find domain, so I'm not getting into that, but we have already seen that in videos. So I'll quickly link those videos so that you can quickly go through those. One is not range, I'll say first. The second thing is codomain. The second thing is codomain. And the third important thing is range. So without these three things mean what? Without domain, codomain and range, you cannot understand or proceed in functions. What is domain, students? Domain is basically the set A. The set A of the function is a domain, right? What is codomain? Codomain, students, is basically the set B of the function, right? So let me write it simply: set A, set B, right, students? Set A, set B. So set A is the domain, set B is the codomain, right? And let me tell you what is the range. So I will write a line, you have to understand what that is. So the set fx, so let me write it first. This is the range of the function. So what is this? What I have written? So for x belonging to A, fx belongs to B. Say for example, I have another element y5. Yeah. For x, so what would have been the domain in this case, students? x1, x2, x3, x4. What would have been the codomain, students? y1, y2, y3, y4, y5. Right, students? y1, y2, y3, y4, y5. What would have been the range? So range is basically the values of x for which you are getting, for what are the values of y that you are getting for the defined values of x for the function, right? For the domain of the function. So basically what fx, so the set which having for x belongs to A, fx belongs to B, those are the range. So here domain will be x1, x2, x3, x4, right? And your codomain will be y1, y2, y3, y4, y5. Say for example, for this function y is equal to x square plus 1. In set A, you have elements 1, 2, 3, 4. and in set B you have another element 18. Say for example, you have another element 18. So will 18 be related by any means? It won't be related by this function, right? So basically the codomain will be 2, 5, 10, 17, 18. But is 18 an attainable value for any value belonging to A? Are you getting this value 18? Are you getting this value 18, students? Are you getting this value 18? No, right? You are not getting this value 18. So that is not a part of range. So basically I can say that range is a subset of codomain. This is very important line. Range, you have to write it down. Range is a subset of codomain. I think this is very clear to you all that range is a subset of codomain. So these are the important concepts. So codomain is actually everything that you get in set P, right? So whenever you see a question which says if f from R to R, say for example, this has been given, which means that your domain has been given and your codomain has been given. So in this question, f R to R means the domain is R and the codomain is also R. R means real numbers. So this, whenever you see this question in functions, students, is a very important point to note. Don't forget it. In examples when we see, you will understand what I'm trying to say. But whenever you see a function f from R to R means the domain has been mentioned as R and the codomain is R. This is a very theoretical part is going on, students, but if you try to skip these parts, your concepts will be weaker. Students, if you skip this part, your concept will become weaker. Hence, it is very important in calculus, at least in functions, you need to strengthen these concepts. This will also help you in calculus, mechanics, physics, everywhere. Yeah, students, this will help you in mechanics as well, understanding functions. Yeah, so there can be a variable function, velocity can be a variable. So again, velocity, acceleration, displacement. So displacement with respect to time, velocity with respect to acceleration, that can be variable, and so on and so forth. So there are several things. Which comes out from this chapter, which is functions and or calculus, and you have to be an expert in that, and that is my motive. Yeah, students. So I think till here your concept is clear. So let me erase out the part that you can see on the board. Now I will quickly take an example, students. Now I will quickly take one example for you. Let's give the heading ways of representing a function. Let's give a heading way of representing a function. So how is the function represented? Way of representing a function. Say for example, there is a set A and A is given as 1, 2, 3 and B is a set that is given as 1, 4, 9. Right, students? 1, 4, 9. So elements of A are 1, 2, 3. Elements of B are 1, 4, 9. So for the first case, if you write it in tabular form, so basically A and you have B, so tabular form is very easy. So just simple, for 1 the value is 1, for 2 the value is 4, for 3 the value is 9. So this is the tabular form of representing a function. This is the simplest form, right? Next is as arrow diagram from the diagram. So basically arrow diagram. Next is arrow diagram. So basically f of 1 is 1, f of 2 is 4, f of 3 is 9. F of 1 is 1, f of 1 is 1, f of 2 is 4, f of 3 is 9. So basically values of x and values of y. I think you are getting it. So basically also you can say that as a formula we have expressed it, right? As an arrow diagram from the diagram, so as an arrow diagram also as a formula also we can say. Third is, say for example, somebody is asking as an ordered pair. As an ordered pair. So ordered pair is very simple, 1, 1, then you have 2, 4 and then you have 3, 9. So this is the ordered pair, right? So this is the ordered pair in which you have mentioned the function. As a formula, if I say, as a function, if I say, so basically fx is x square, right? So 1 square is 1, 2 square is 4, 3 square is 9. So the formula, you get it in this way, right, students? So these are some of the forms of representing or mapping a function, and we have been discussing this. This is a very basic part. I think this won't be tough for you. Understanding this won't be tough for you. Let's quickly see an example. Say for example, I'll quickly draw a diagram, and you have to say what is the domain, what is the codomain, and the range of the function. Yeah. So let me draw one diagram. So I'm drawing two set. So this is set A, this is set B, right? And they are defined by the function f, right? Minus 1, 1, 2 and 3. Minus 1, 1, 2 and 3 are the four elements of set A. 1, 4, 9, 16, 1, 4, 9, 16 are the four elements of set B. Minus 1 is mapped to 1, 1 is mapped to 1, 2 is mapped to this, and this is mapped to this. So these are the mappings that you can see in this function. You can also relate to what this function is, but my agenda is not that. My agenda is finding the domain, students. So the domain here is what? What is the codomain and what is the range? What is the range? Students, what is the domain? So domain is basically the values that are available in set A. So basically it is minus 1, 1, 2 and 3. So this is the domain of the function f. Domain of the function f. What is the codomain? The codomain is basically everything that exists in set B. 1, 4, 9, 16. 1, 4, 9, 16. Note, students, although 16 is not attainable, but it is in codomain. Since 16 is not attainable, students, it is not in the range. Right? Since 16 is not attainable, hence it is not in the range, and hence the name range. Range means what? Something that is in your range, that is attainable. Since 16 is not attainable, hence 16 is not in the range. 1, 4 and 9 is the range of this function. From this diagram, students, if you can understand this figure, if you can understand the values till here, I think you have understood whatever theory we have discussed in the last 15, 16, 17 minutes. Right, students? Whatever theory we have discussed behind this, if you understand this diagram and how we found out this value, I think you are clear with this. If you are still having doubt in this, I'll request you to go back and understand that and then come back again. Right, students? So basically you can see that codomain will either be equal to range. If 16 wouldn't have been there, then codomain would have been equal to range, or codomain will be greater than range. Codomain can never be less than range. Right, students? So I told you that range is always a what, students? What did I say before that? Range will always be a subset of codomain, which you can clearly see over here. Right? So let's move to the next part. Students, now there are two important concepts. One is onto and into. Onto function and into function. Onto and into. So let me tell you first about onto functions. So onto functions are basically those where the range will be equal to your codomain. So let me first tell you, onto function is also known as surjective function. Surjective, surjective function. Don't get confused in examination. Onto function is also known as surjective function. Into function there is no name. Yeah, don't need to worry. Onto function is also known as surjective function. Same nomenclature. If somebody says onto function or if somebody says surjective function, they are trying to mean the same thing. So basically, what is an onto function? So if a function f defined from a to b, this means a function f is defined from set A to set B, right, is such that each element of B is the f image of at least one element in A. If you are writing it down, students, I am not writing it over here. If you plan to write it down, you need to understand. I am just making you understand, but if you want to write it down, you can write it down and then maybe you can read it on your own. So basically what I am saying, if the function f from A to B is such that each element of B, each element of set B is the f image. So basically f image, right? So this is the related to this, is the f image of at least one element in A, then we say that f is a onto function. So basically what it means to say is, say here are some points and here are some points. So all will be pointed. There will be nothing that will be left behind, right? This is what it wants to say. So basically all the elements that are here, the example that we saw before that was not onto, because we had one value, I think that was 16, which was left out. That was not related to any element in A. And what onto function says is that each element of B, this is A, this is B, each element of B is the f image of at least one element in A. Then we say that f is onto function. F is onto function denoted by a onto from A to B. Students, understand over here, always your range will be equal to codomain. I think you can understand what I am trying to say. If range is equal to codomain, or all elements in set B are mapped to at least one element in set A, this is known as onto functions or surjective functions. I think this is very clear to you all. Yeah. So what is surjective mapping? You know now, right? So basically here you will see the range of the function f will be equal to the codomain, that is onto function. Next part, students, this was onto or surjective functions. Next part, let's erase it over here only and let us see what is into function. What is into function? Onto and into. Yeah, onto and into. So this is the difference. So f from A to B, what happens in this case is, let me tell you, there is at least, so again you can write it down. So from if a function f from A to B is such that at least one element in set B, which is not the f image of any element of A, then f is a mapping from A to B is a into function. 4, 1, 2, 3, 4. This is mapped to this, this is mapped to this, mapped to this, mapped to this. So you can see one element, like the example that we saw, which was not mapped to any element in the set A. One element in set B remains, which is not mapped to any element in set A. Then this mapping, the mapping f, will be into mapping. This mapping will be into mapping, and in into function, which has no other name, like onto had surjective, into function is only called into function unless somebody discovers or invents some name. Into function, basically here the codomain, the number of elements in codomain will be greater than range. In onto function, students, codomain is equal to the range, and in into functions codomain is greater than range. Can ever codomain be less than range, or can range be greater than codomain? That is not possible. That is not possible in any cases. That is not possible in any cases. This is how fundamentally clear you have to be, students. That is not possible in any cases. So I think now you understood what is your onto and into functions. What is onto and into functions. Now students, you have already seen relations. I have already taught you relations before. I have already taught you one. I have already taught you many one and one many. I have already taught you, if you have not seen the video, again It will be my request to go back and understand what is one one, what is many one, and what is one many relation. And I had told you, so this is many, let me just correct, else many will say what have I written. So many one, many one, and one many. These are the three types of relations that we have. These two are functions, these two are functions, this is also a function, this is not a function. Why is this not a function? We have seen graphically also how in a graph you can say something is a function and something is a not. So let me tell it over here only in short, although I link the main video. So basically, if you have a straight line, students, if you have a straight line, so for a straight line, this is y-axis, this is x-axis. Understand the concept very clearly. I will not repeat it again in all the videos that I make. So you can clearly see for one value of x1, you are getting only one value of y1. x2 if you put, you will get y2. So basically in this case what you are getting, for one x1 you have value of y1, x2 you have value of y2, x3 you will have y3. So it can be like this, a straight line, it can be like this, it can be like this, whatever. So if the graph is like this, a strictly increasing graph, again monotonicity, and speaking about monotonicity, so this is looking like one function. This is looking like one function. So when is this something called one function? So one function, if I define f from a to b, is said to be one. So one function is also called, let me again introduce another new name for one, is injective. Right students, one function is also known as injective function. Onto function is also known as surjective functions. And if a function is one onto, if a function is one and onto, it is called as bijective function. It is called as bijective function. Let me mention it, bijective. So bijective is the combination of injective plus surjective, right? So injective plus surjective is bijective. So if somebody is saying that prove that this function is bijective, they are saying that prove that the function is injective, or prove that the function is one, and prove that the function is surjective, or the function is onto function. So I gave the description here itself. I have digressed from the topic, but this is one important question that has come, you can see several times that has come up in your IIT joint entrance examinations. So that's it. So yeah, let's move into one or injective function. So basically, what is one? So for one element in this set A, you will get only one element in this set B. Right? Very clear. So you will have different elements of set A. We have different images in set B. Right? There will be no two elements that will have the same image. So basically what I am trying to say, if you put f of x1 is equal to f of x2, then x1 should be equal to x2. So if you put f of x1 is equal to f of x2, you will have x1 is equal to x2, because these are distinct characters. There will be no same things, right? So if of f of x1 you are getting f of x2, so x1 should be equal to x2, then only you are getting these two values as same. So this is one thing, one concept that you will have to apply if you are trying to prove a function is one. Right students? Put f of x1 is equal to f of x2, and if you are able to prove that x1 is equal to x2 from that, hence you can say that the function is injective or one. So this is the concept to prove that a function is one. So do note it down. This is an important concept. We will be solving it, we will be using it while we solve the numericals. Yeah. So next, let's move into what is many one, definition of what is many one. Say for example, I have a parabola, or say for example, I have y is equal to mod x. I have y is equal to mod x. So something which is not necessarily symmetrical about y-axis, but this graph is currently. I'm not saying something symmetrical, it has to be. So let me not speak it right now. Say for example, y is equal to mod x. If you have y is equal to mod x, looks like something like this. So you have, so for this point, for this value y1, you will have two values of x, students, right or not? So for x1 also you will get y1, and for x2 also you will get y1. So basically if you plot it, so for x1, x2 you will have the same value as y1. Same for x3, and say for example x4, you will have a value of y2. So it can be two values or it can be multiple values. Say for example x1, x2, x3, you are getting a single value over here. So this is many to one. This is 2 to 1. So 2 to 1 is also a category of many one. So many to 1, if you have a many to 1, that is also a function. So a many one is basically you have multiple elements in A that has corresponding one image in B. That is your many one function. So some functions, these functions look like this. It can be a parabola. So this is like this. If you draw a parabola like this or a parabola like this, whatever. So all these will be what? These will be many one functions. These will be many one functions. Now one many is basically one till many. How this graph will look like? Say for example you have a circle. So basically over here if you see, for this value of x1, you have one value y1, you have one value y2. So here for x1 you are having y1, you are having y2, not these maybe. So 1 till many, these circles and all, ellipse and all, hyperbola, so hyperbola, so I will get to that later on. So basically circle, ellipse, if you see, or maybe some graph wherein you draw a vertical line, it cuts the graph at more than 2 points. If you draw a vertical line to the graph, if you draw a vertical line at any point and it cuts the graph at 2 points, then it is not a function, it becomes a one many relation. So this is not a function, this is a mapping, yeah, it's a one many relation. It's a one many relation, students. It's not a function. I think it's very much clear to you all. You are able to understand what I am trying to say over here. Right, students? I think I have given my best to make you understand what is one, what is many one functions, these two are functions, and what is one many relations. Yeah, that's it for this part actually. So how do you understand? So now using monotonicity, why I said monotonicity was very much required is here. Say for example you have a strictly increasing function. So I am drawing a strictly increasing function. So this is x-axis, this is y-axis. So this is a strictly increasing function. So a strictly increasing function means your f dash x will be greater than 0. A strictly increasing function means your f dash x will be greater than 0, or the slope at any point of the graph. Say for example here, slope will be what? Slope will be positive if I draw a slope. So f dash x is nothing but a slope. If you know, so you will read that in application of derivatives, f dash x is greater than 0, or a strictly increasing function, you can see the graph, it's strictly increasing, is always 1, is always what, students? It always a 1 mapping or 1 function. A strictly decreasing like this, whatever, strictly decreasing from only one, not 2, 3 lines in a graph, it will not be a function. So say for example like this a graph, it is also a 1 function, it is also a 1 function, right? A strictly increasing, so don't make it f dash x greater than 0. So this is not the criteria for 1. Basically a strictly increasing or a strictly decreasing, these can be what? These are actually 1, these are actually 1 functions, or injective mapping or injective functions, right? I think this is very much clear to you all, right students? Next thing, many one, if you see a parabola, I already mapped it to you, a parabola, a periodic function, basically a periodic function, even function, those will be what? Those will be many one functions. Those will be many one functions. So basically students, there are 4 types of mapping and 4 types of function. One is 1 into. The first one is 1 into. The first one is 1 into. The second one is 1 onto. or bijective students. I just told you this is also called bijective. One is 1 1 into, one is 1 1, 1 1 is known as injective, onto is known as surjective, 1 1 onto is known as bijective, that is surjective plus injective, injective plus surjective, whatever. So many 1 into, and the fourth one is many 1 onto. These are the 4 types of functions: 1 1 into, 1 1 onto, many 1 into, many 1 onto. Right students, let us now quickly see or map this here. Just let us quickly map this here. The first one was 1 1 into. So 1 1 into students will look like something 1 2 3 4 5 6. This students, this is what this mapping from A to B, F, this function F is 1 1, this function is 1 1 into 1 1 onto. This is 1 1 onto. When will it become 1 1 into? This is 1 1 onto. Say for example there is one element 7, this will become 1 1 into, because here the codomain is greater than range. Another element 7 is there which is not mapped to any functions. Clear students? Very much clear to you all? I think this is clear to you all. Next point is, let me show you the next point. Say for example P Q R S. P Q R and this is S. Okay, and here let me write 1 2 3 4. 1 2 3 and 4. Let's for example P is mapped to 1, Q is mapped to 2, R is mapped to 3, S is mapped to 4. Right? This is what? This is many 1, you can see clearly this is many 1. Is this onto or into? This is into. This is into because you have one element over here that is existing. If I remove this element, this will become 1 students, this will become many 1 onto. As simple as that. This is the application and this is the overall concept of mapping of functions. Quickly I will get you to the first example, solving the first examples we will see. Just write down the first question. Let for example, I'm writing f from R to R is defined by fx is equal to 3x plus 5. You will have to prove that fx is, that this mapping is, or the function is bijective. You have to prove that it is bijective or 1 1 onto. So students, I have already told you, if you get a question from R to R, this means the range is given as R and the codomain is given as R, right? You have the line fx is equal to 3x plus 5. So I have told you to prove, you have to write what? F of x1 is equal to f of x2, and if you get x1 is equal to x2 from that, then fx will be what? Fx will be what students? Fx will be your 1 1 function. For ff to be 1x function, this condition has to satisfy. Also you can see fx is equal to 3x plus 5, y is equal to 3x plus, this straight line is a straight line. We either will be strictly increasing or decreasing, whatever. So and it will have to be a 1 1, but let me use this method. So basically f of x1 is equal to f of x2. So if you put over here, so you will get 3x1 plus 5 is equal to 3x2 plus 5, and from here 5 cancel, 3 cancel, so x1 is equal to x2. Hence you are getting this x1 is equal to x2. Hence students, this is a 1 1 function. Hence students, this is a 1 1 function. Now how do you prove that it is your onto or into? How do you prove that? So already I told you range is R, definitely y is equal to 3x plus 5 for all values of x, for all real numbers of x, this function is defined, and for all real x, what is the range that you will get? What is the range of this function students? The range of this function is R. And what is the codomain that has been given? That the codomain mentioned is R. So basically the range is equal to codomain. The range is equal to codomain. If the range is equal to codomain, then the function becomes onto function. So the function is 1 1, the function is onto. Hence we can say that fx is equal to 3x plus 5 defined by this relation, defined by this mapping, is a 1 1 onto or a bijective function. So this was a solution. This is how you have to solve problems of these chapter, mapping of functions. Let me quickly move on to the next question. Let me quickly move on to the next question for your better understanding. Students, open your R.S. Agarwal, R.D. Sharma, whatever you have, quickly go to the chapter and solve numericals pertaining to this. If you have any difficulty, you can come back to the comment section and you can ask me any doubt if you have. Let f be defined from R to R, wherein fx is equal to x square upon 1 plus x square. So you have to find that this function is what, injective or surjective, 1 1 on 2. So you have to say comment about everything. Yeah, so this is the question, students. Now see, let me quickly move into the solution part. You can see I have to rush now actually, because I have already taught you the concept and things have become very easier for you to understand. So this fx is, students, what? It is an even function, right? So what is an even function? F of minus x is equal to fx. If f of minus x is equal to fx, so odd and even functions, I have already made the video, do watch that. F of minus x is equal to fx, then it becomes an even function. So if you put minus x over here, since it is a square, it will become fx. So f of minus x will be equal to fx. Hence it is even function. Now fx, even functions are always what? Symmetrical about y-axis. It is symmetrical about y-axis. Hence, students, a symmetrical function about y-axis like this or whatever be this side, it has to be this side. So these functions will be what? These will be what? Your many one function. This function has to be a many one function. So directly looking at the function type, odd or even function, you can also comment whether a function will be many one or 1 1. So if a function is even function, students, you can write it down, this concept. If a function is even, then it has to be a many one function. So I quickly got it into this. So now if this is onto or not or whatever, so let's prove that. Let's prove it's onto or into function. Now students, tell me what is the codomain, of this function? So codomain has been mentioned as R. So let's quickly find out what is the range of this function. So y is equal to x square upon 1 plus x square. You know how to find range, right? You have to express x as y. So y plus yx square minus x square is equal to 0. You have, or maybe I can take it this side. Actually, let's take it this side only. So x square minus yx square is equal to 0. So I take x square common, 1 minus y is equal to y. So x is y upon 1 minus y root. So this is the value of x, students. X is equal to y upon 1 upon y. So I can write this as plus minus y upon 1 minus y. And clearly you can see, you can find the range over here. So the range will be 0 till 1, not included. 0 till y is not equal to 1. So you can find the range, students. I am not finding the range over here basically. So if you see, the range of this function fx is from 0 till 1, right? From 0 till 1, which is clearly not equal to the codomain of the function, which is given as R. Which is given as what? Which is given as R. If range is not equal to codomain, hence fx is not onto, this is an into function. Basically, this is an into function because range and codomain are not equal. Range not equal to codomain. Hence, this is into function. Hence, this function is many one and into this. So the question was to prove that this is not surjective, what a bijective function. So basically, this is not, because this is into, this is not onto also, and this is not 1 1 also. This is many one functions. So students, I think I'll stop the video over here. If this concept was very clear to you all, I'll request you all to subscribe to my channel, like this video, and if you have any question, you need to go to the comment section. So there must be many chapters which I have mentioned in between that you have to go through in order to have a clear understanding of this entire chapter. Thank you so much, students, for your time. In the next video, we will be going into possibly inverse function, and we will be seeing composite function, and I think that will be the end of the entire series of functions. Thank you so much for your time.